Good afternoon, and welcome to today's webinar, Glazing, an Integral Part of Biophilic Design. This event is brought to you through Architectural Record as part of its Academies of Digital Learning program, a program that allows architects to fulfill some or all of their annual CE requirements within individual education academies focused on specific areas of design interest. This webinar is sponsored by the National Glass Association. Today, we are joined by Irmela Joku-Sol, Stephen Selkowitz, Thomas Culp, and Lisa Heschong. Irmela Joku-Sol is the Technical and Advisory Advocacy Director for the National Glass Association. Lisa Heschong, FIES, Architect and Principal for TRC, Heschong Mahone Group. Stephen Selkowitz is Principal, Stephen Selkowitz Consultants, and Tom Culp, PhD, is owner of Birchpoint Consulting. I'm your moderator, Dean Evans. I direct the Center for Building Knowledge at the New Jersey Institute of Technology. Thank you for joining us. Please remember, as the webinar proceeds, to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is also being recorded and archived on architecturalrecord.com/webinars. Before we begin today's presentation, please enjoy this brief instructional video on how to use your webinar console.
Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
This course is approved for one AIA-LU HSW, one AIBD P-CE, and one 0.1 IACET CEU credits. It may also qualify for learning hours through most Canadian architectural associations. To qualify for credit, you must watch this webinar for a minimum of 45 minutes. Following the event, live webinar attendees will receive an email with instructions on how to view and download your certificate of completion. You do not need to be an AIA member in order to receive a certificate. An archived version of the webinar will also be posted to the ArchRecord CE Center website within 24 hours, so that any of your coworkers who couldn't attend today or any other colleagues who might be interested in the topic can easily access the information we will be presenting. Please note that those who access the archived version will need to complete the entire webinar and then also take a 10-question quiz in order to receive credit. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and or use of the presentation without written permission from the speakers is strictly prohibited. Today's learning objectives are: 1, define the tenets of biophilic design and its impact on human physiology and well-being. 2, describe 2 ways that daylighting can affect occupant comfort and productivity. 3, explain how glass elevates and facilitates the goals of biophilic design and daylighting. And 4, analyze how glazing material might be used to shape the human experience of the built environment now and in the future. And now I'm excited to turn over the webinar to today's first presenter, Irmela Joku-Sol. Irmela.
Thank you, Dean, and hello, everyone. Thanks for joining us today. Today, we will explore biophilia. What does it mean, and how does it fit into each of our daily lives? I can tell you, it's not a new concept. It's what Frank Lloyd Wright called organic architecture more than a century ago. Some architects have coined it biomimicry, where it has been used by designers to help solve human problems. Biomimicry is defined as a study of emulating or mimicking nature. From centuries ago, designers and architects looked at nature as a huge source of inspiration. Glass is used to look outside, get a feel for the outside, and gives you the connection to experience the outdoors while at work inside of a building or in your home these days. A paper published in International Journal of Wellbeing in 2015 states, "The biophilia hypothesis argues that since our ancestors evolved in wild settings and relied on the environment for survival, we have an innate drive to connect with nature. The stress reduction hypothesis suggests that spending time in nature triggers a physiological response that lowers stress levels. And yet a third idea, attention restoration theory, holds that nature replenishes one's cognitive resources, restoring the ability to concentrate and pay attention." On your screen, you'll see the Falling Water, which was designed by Frank Lloyd Wright. It's a home in Pennsylvania. This was something in which he wanted to bring the home in outside, but make it to where it fits in the environment as well. Lance Davis of the General Services Administration presented earlier at the National Glass Association Glass Conference, where he shared this Reskin project of the GSA Edith Green Wendell Wyatt building in Portland, Oregon. As you can see on your left-hand side, the radical transformation removed the precast concrete and installed a highly efficient curtain wall in the middle, as well as your right-hand image. This gave back about 22 inches of each floor for a total of 33,000 square feet of additional leasable space. Now, he mentioned that this facade, is different in response to the sunlight that falls around it as the sun moves from east to west. His solution, he said that the solution was not cheap, but with the additional rent, its payback was years, not decades. And this particular building has won the AIA COT Top 10 Award winner twice. Here's a look from inside of the building. As you can see, the glass brought in the views and the outdoors into the very secure building. You have to have security in order to get in and out of the building. And so this is a way for them to bring the outdoors in. Now, to discuss the value of views, I'll turn it over to Lisa Hischel. Lisa?
Pleasure to be with this group today. I have been working in daylighting for pretty much my entire career, researching it, looking at energy performance of daylighting, helping architects to design buildings that are more energy efficient. But recently, I have come to really focus on the importance of view. If you think about it, there really isn't any other reason to have a window in a building other than view. We can do almost every other function of a window better with a different building system, whether it's ventilation or heat control or acoustic control and so on. But windows provide this unique ability to see outside. And it turns out that I think it's enormously important and undervalued in our consideration of designs. Typically, when I have a conversation with somebody about views, the conversation lasts one or two sentences, in that everyone will acknowledge that they're important, they're valuable, they should be considered, and they haven't thought any further than that about what are the aspects of view that really interact with us to make them so valuable. I would argue that part of this is that we've taken them for granted for so long because they're everywhere, they're so natural. We haven't had to think about it very deeply. But for the last couple of years, I've been doing a really deep dive on what is going on with views. And it turns out that, as I'm sure most of you have heard, there's plenty of studies showing that modern Western humans spend an enormous amount of their lives inside of buildings from the time you're an infant until you're an old person. Studies have shown overall that that number is over 90% of our lives are spent inside of buildings. So buildings are now where we live. They're our natural habitat. But within those buildings, we also have studies showing us that not as many people as you might think actually have access to windows and views. One large survey of American office workers reported back that 1/3 of them reported they had no access to any view during their workday. Another study in California looking at existing office space found that 2/3 of existing office space had no access to daylight. I've spent a great deal of time studying educational design, and I can tell you that there are thousands and thousands of classrooms and schools across the country that were built without windows. The argument was to reduce energy use or to avoid distractions or to make the buildings safer and more secure. But the net result is there's lots of students that have no access to windows. And there's millions of people worldwide who are working in windowless buildings. Just one factoid, Japan alone has 10 million square feet of underground buildings. So not only is this our current problem, but I would argue it is also under threat to get worse. Many of you may have heard of new electric lighting sources that are tunable, dynamic. This is often sold as human-centric lighting, but even more, it is often also sold as a substitute, a replacement for daylight in our spaces. It's now good enough. We can have, now that we know that daylighting is important to our health and well-being, maybe we can just simulate that with electric lighting instead. Similarly, there are lots of technology companies that are looking to simulate the effect of views. You don't need a window in your buildings. We can simulate that. We'll put a big screen on the wall and we'll give you a beautiful view of Tahiti. And isn't that wonderful? Doesn't that make us all happy? So there are these increasing technology solutions that are promising biophilic benefits. And the question is, are they really sufficient? Is that a reasonable substitute? And I would argue that no, we're overlooking too many other aspects of what's going on with daylighting and view. So to put this together, I've created this little mandala that tries to capture some of the variety of ways that our brains and bodies interact with window views. And importantly, understanding that all of these systems tend to influence each other and overlap. Human beings are highly visual animals, and a huge proportion of what we understand about the world comes through our eyes, through our visual processing centers. Whereas a dog is very interested in smells in terms of understanding their world, a bat is listening to sounds, human beings' cognitive processing is primarily devoted to understanding the visual environment. In addition, there are many other physiological processes that are involved with view. And as I tend to say, our eyeballs are basically a little piece of brain that has been expressed out onto our face so that we can sense the outside world. And our eyes and our brains are working very closely in concert. So we don't have time today to go into the science behind all of these pieces, but I'm going to just touch on them briefly in the next slide to give you a sense of the depth of interaction that our bodies and brains have with this visual information. So, for example, views importantly contribute to eye growth and development in young children. 100 or more years ago, school designers assumed that children need views to the outside in order to have proper visual development. Turns out we're finding that that is very much the case. Within the last 20 years or so, there has been an epidemic growth in myopia, the scientific word for nearsightedness, where there are populations of children in Asia and Singapore and Seoul where up to 90% of the children are now found to be myopic. And the question is why? The current assumption is lack of circadian stimulus to the eye in terms of understanding the brightness of the daytime environment and the darkness of the nighttime environment. That brings us to the larger issue of circadian rhythms. I'm sure most of you have heard about the problems with sleep and with digital devices interrupting our sleep patterns and causing a lowering in sleep quality. Well, it turns out that the primary circadian stimulus to keep our rhythms in balance with our sleep-wake cycle and help us have the highest level of physiological functioning come from the stimulus through the eye. And we need bright daytime light during the day. Our eyes are most sensitive to the color of the blue sky. And so it's really seeing that blue sky light that helps tell our bodies it's daytime. And then we need exposure to biological darkness at night, so lack of that blue light to help us sleep better, process memories, restore our bodies, and get ready for the next day. And so this cycle of daytime exposure and darkness at night contributes to all kinds of fundamental metabolic and immune response and memory development. Another aspect that windows provide is understanding where we are in the world. There have been studies looking at how we develop a physical map that's represented inside of our brain, and windows strongly help reinforce this understanding of where we are, both in space and also in time, what time of the day it is, how we fit in with that sense of time. There's another area of psychological research that's extremely interesting, looking at the function of daydreaming, which has also been called mind wandering. It's connected to something called the default mode network that you might have heard about. And this is all what our brain is doing when it's not on a given outward task. But it turns out that our brains are spending about half of their time flipping back and forth between outward directed tasks and this inward directed understanding of what we need, what we might be doing next. It's been referred to as the autobiographical self. And having the ability to relax and look at a non-threatening piece of the world outside is very supportive of this daydreaming and an ability to pay attention to what it is that you need emotionally, physiologically, what your body needs, and so on. And then finally, connection to the outside world, in addition to creating cognitive maps, allows our brains to synchronize everything that we're doing and put it into a context and a structure that makes it more accessible and helps reinforce our sense of reality. Now, like I said, that's a ridiculously quick overview, but to try to put this into context, real estate agents have known since the beginning of time, since real estate agents became a thing, that views have a huge value. And if you think about it, this is actually kind of strange. You can have an office space or a condominium on one floor of a building that is worth twice or 4 times or even 10 times as much as the equivalent space on the other side of the building without the view or down at the bottom floor. And what that's saying is that the value of the building, the location, all of the amenities that are provided by the building are equal to one thing, and then the view is equivalent to all of that value that's provided. How is that possible? How is it that human beings are valuing view at such a very high economic level? I challenge you to try to think that through, what it is. I've tried to pull all of these ideas and research evidence from a variety of different fields into a book that I've just published that I would say will help you pursue some of these ideas more deeply. It's broken into four different chapters. The first looking at the science, the physiology, and the cognitive performance. The second one looking at how we perceive the world and how daylighting contributes to our perceptions. The third looks at the history of daylighting and views and architecture and different building types. And the final group looks at our attitudes and cultural priorities, and especially discusses the concept of biophilia and the potential threats to biophilic design that are currently arising. So I'd like to leave off there, and we can come back and pass the baton here over to Steve Silkowitz, who can translate some of these ideas into the more specifics of how we bring it into practice. Steve?
Oops. Thank you, Lisa. We're struggling the slides here. There we go. Okay, so I hope at this point you're convinced of the value of view. I'm going to sort of add the other piece here, which is to say that in delivering that view to building owners, clients, and occupants, we want to make sure that we're still addressing the energy, carbon, and climate change problems that we've had for the last couple of decades, and will get probably even worse going forward. I've spent the last 40 years also looking at the aspects of daylight and glare from the perspective of leading a group at Lawrence Berkeley Lab. There have been something like 400 reports published by that team over that period. They're accessible on the URL that's shown here. Lots more detail, lots more information. A lot of it is research-oriented, but some of it is design guides, tools, data, and so on that will be useful. I'm going to try to frame this problem in a way that brings back in the energy, climate issues with view, comfort, and other issues like that as well. So the first thing to look at is what are the criteria and metrics that we're going to be using. So Lisa's touched on many of the topics here listed in red, the occupant-centric aspects of glazing design. I'm going to reinforce that a bit with the ones in blue, looking at energy and carbon, both from an operating and embodied point of view, and then looking at the grid that supplies power for most of our buildings as well. There's a whole host of other issues shown on the right here, critically important in most buildings. They've got to be addressed beyond the scope of what we can easily talk about here, though. So if we talk about glass, sort of the underlying element here, glass is a transparent filter, and I want to emphasize the filter part and emphasize the fact that we want to be able to change the properties of glass because the environment, both inside and outside the building, are changing all the time as well. So this is really about glass that allows you to manage view, but also manage daylight and solar gain. This is a plot of about 5,000 different glazing products that are available on the market today. And they're shown by their light transmission on the vertical axis and their solar heat gain on the horizontal axis. And the good news is that we have all these options. But if we look at the two green dots here. This morning when I woke up, it was cloudy and overcast in the Bay Area. And what I would have liked would have been glazing that had a dot on the upper right there. High transmission, plenty of solar gain was good. But it's now bright, sunny, and it's probably going to get a bit warm this afternoon. So I'd like to change those properties and bring it down to the lower left. I can do that with the emerging smart glass technology that's out there, but I can also do it with a host of operable shading systems that have been available for hundreds of years and are still being improved. So we want to be able to moderate and change the properties of the glazing system. Now, we're not just dealing with glass, we're dealing with a whole ensemble. I'm just trying to show this in this sort of aspect of scale here. To the left, we can talk about things that are much thinner than glass coatings. And a lot of those glazings I showed you in the prior slide had coatings on them. But going to the right, we can add shading systems, we can add framing systems, and we can even use the building design itself, the footprint, the floor plate, as a way of managing daylight, glare, and view through the building as well. If we dig in a little bit deeper, I've got on the left here in the orange bullets, if you will, all the functional aspects that glazing is doing. So glazing isn't just a look through, it's got to be insulating to keep you warm and comfortable. Excuse me. We can manage airflow through the building. We can use glass as a heating element. We can use glass to make power these days, put PV on it. We can redirect daylight deeper into the space. There's a host of functional aspects that can and will and need to be done in addition to managing daylight and view. And then, of course, this is just the facade. So this is a piece of a much more complex building system shown on the right there in terms of lighting, HVAC, and the grid that sits behind it. And in the center of all this is the occupant and sort of the crucial person or the people that are going to be driving how all of these things are managed over time. One of the key issues here is cost. There's all kinds of wonderful things that you'd like to put in a building, and many of them get value engineered out. We turn to cost-benefit analysis, to payback time, which is the sort of the blue box here. How much do I save each year? How much do I pay at the front end? How fast does it pay back? I want to argue that if you're aggressive about the facade in the green box on the left here, we ought to be able to do such a good job that we can reduce the heating and cooling system size, the chiller size on the right there, which has a cost benefit to it. And if we're going to put PV either on the building, near the building, or someplace else, that's a cost as well, and we can offset some of that cost. So if we're aggressive in thinking about how the facade is going to operate, we think we can shift costs from other parts of the building back to the facade, so that value engineering exercise doesn't always end up taking functionality away from what we're trying to design and build. The problem with what I just showed, if you go to your engineer and say, you could reduce the chiller size because I've got this great facade system with shading and daylighting involved in it, she's going to say to you, how do I know it's going to work? So now this slide, I'm looking at the operational side of the building. The building is now built, it's occupied. On the left-hand side are the drivers that minute by minute, hour by hour change what we're going to be doing. And then the question is, how do we manage that? Do we rely on sensors and controls? Do we rely on people? Do we rely on part of both of them? I mean, I think the answer is probably both, but exactly how we manage that is a real challenge. I'm going to jump into what makes the challenge even worse is the fact that we've got an ecosystem here that is complicated, and I'll just sort of subtly say non-optimal. You've got your design team, many of you on the call today. In the middle here, you're dealing with the glazing industry, the facade industry, the building industry in the upper portion, which is complex in and of itself. On the right-hand side, once the building's built and occupied, you've got to deal with the owners, with what occupants need and want over time, and the ongoing maintenance and renovation that happens in all buildings. And the criteria on the left here, skill, skill, cost, risk, and time sort of infiltrate in all of these different decisions. So this is a real challenge. To end on a more optimistic or on an optimistic note, good designers can solve these problems and do it. This is a project we were involved in with the New York Times about actually almost 20 years ago at this point. The building had largely been designed with the idea of view and access to daylight in mind. That floor plate on the right was notched in the corners, and was basically designed so that every space had a view to the outside. The partitions, the low partitions, were outboard. The private offices were inboard. So people thought through carefully the idea of how do you at least give some access to view and daylight. But now you have to control it. And on the sort of in the middle there, you see the facade. It had fixed exterior shading, really good glass, but both of those are fixed. And the thing that needs to happen is you need to be able to manage these in a dynamic way. So these were operable shading and operable lighting, or dimmable lighting, came into play. This was the first and largest use of those technologies in the US. Unfortunately, they've not been widely used since then, but that's where we need to go in terms of where the technology is going. And then finally, that project was done with a mock-up and a custom mock-up for that one building. We're able now, this is a mock-up system at Berkeley Lab called FlexLab, where you can build in a 600 square foot space. You can do all the integration. You can do the integration of the glazing, the shading, the daylight dimming, and all that, and make it work as a system. You can bring people in. You can study what their preferences are, how the building actually works. So we're beginning to work some of the bugs out of these systems and getting to the point where we can more reliably design and then implement these solutions. So finally, I think there's a win-win-win here. We can do what we want for people, the view and daylight that Lisa started with. We can add value for the building owners and operators over time, addressing the energy issue. And if we address the energy issues and carbon issues for every building, then cumulatively we'll be helping to solve the global greenhouse gas problem. The challenge here is to do this at scale. And in order to do it at scale, what we need to think about is getting a lot of this stuff into codes and standards. So I'm going to pass this off to Tom Culp with two transitional slides here. One is showing the views or the perspective on the space we're talking about in the upper left here of the occupant. But in the end, this has to be reduced to an electrical engineering, a thermal engineering, physical design, where all the pieces and parts work and they meet or exceed the requirements of code. And this is an ongoing challenge with the properties of, but where the properties of glass and windows become really critical. This dynamic that I started with of sort of letting light and view in when you want it, but keeping daylight or glare and solar gain out. And again, one of the purposes of code is to try and balance this out in a reasonable way. Tom is going to tell you how to do that.
Okay, thank you, Steve. And as Steve kind of hinted at, my work really focuses on building codes, specifically energy efficiency codes and green building codes and standards. How do we kind of translate some of this good design into everything from a base code, minimum requirements, up to green building programs and things that are really trying to push the envelope on the high end. And so I'll kind of touch on that today, really focusing more on the views aspect versus energy efficiency. Although we maybe in the discussion part we'll talk about that, how we can overlay and do both at once. One does not preclude the other. So as it says here, and as Lisa and Steve spoke about, especially Lisa, that, it's recognized there's numerous studies about how providing quality views improves occupant health and well-being, student learning, patient recovery, office productivity, things like that. And so it's well recognized that it's an important part of a high-performance green building. So how is that translated into green codes and programs? And then we'll talk a little bit about the base code as well. So it is recognized. So view is included in several green standards. So one is the latest edition, just recently published, is the 2021 International Green Construction Code. This is part of the iCode family. It's done in collaboration with ASHRAE 189.1, where ASHRAE writes the technical content, ICC writes the administrative content, and they promote it jointly together. But if you dive into there, for certain spaces, specifically classrooms, offices, and patient rooms, where all these studies show the greatest benefit, at least 50% of the floor area must have a direct line of sight to view fenestration. And then there's a lot of details in there about what qualifies as view fenestration, and in terms of visible light transmittance, whether it can or cannot be obscured or shaded and things like that. It has to be within a certain distance, so it doesn't count to have be sitting 100 feet away from a tiny little window. And then it also relates to appropriate measure of glazing area to floor area. And if there are questions, we can get into specifics, but I just wanted to point out that yes, the Green Construction Code does have a new views requirement for these spaces. And this is on top of the daylighting requirements, where within the Green Code, there's also minimum side light effective aperture requirements, as well as distribution of window requirements on the north, east, and south sides. So it's kind of combining view and daylighting, which are not the same thing. We'll probably talk about that a little bit later. Also in the Green Codes and Programs, now more on the standards or program side of things, LEED version 4, actually version 4.1 now. It's well known there's 1 point credit for quality views, and this is providing unobstructed line of sight to the outdoors for 75% of your regularly occupied floor area. And then there are some specific criteria for meeting that. Hopefully most of you are familiar with that. If not, we can talk about it a little bit more. But you have to do extra things. So you either provide multiple lines of sight, or you have good quality of exterior view. So it's not just good enough to look out at a brick wall across the alley. You provide flora, fauna, movement, or it can also be using aspects such as view factor, which has to do with the kind of the angle and the distance you are away from the window. So if you're far away and have a narrow angle, you will have a very low view factor that doesn't qualify. It's not on the slide, but I should point out there, if you're in the healthcare space, there's an additional point you can get. You have to provide these views for inpatient units, but also for the other spaces. If you show your perimeter area is within 15 feet as a certain percentage of your floor plate, that earns you an additional point credit. And again, that's aimed at providing a maximum amount of views for a maximum number of spaces in the entire building. And finally, there's a new pilot credit that's now out there in version 4.1 for non-regularly occupied floor. If you notice above, this is for regularly occupied floor area, and they define what that is. But for other spaces where it's more transient, lobbies, things like that, they have a new pilot credit for also providing views in those spaces. So make sure you look into that. But again, recognizing the value of views in these spaces. Second one there on the slide is worth noting. If you get involved with any sort of governmental work, GSA, many people say, is the largest landowner in the country, or landlord in the country. They house over 1 million federal employees in public building facilities. And so they have P100, which is the facility standards for the public building service, which is part of GSA. And they have kind of a baseline and high performance tiers in there. And for the high performance tiers 1 through 3, you have to provide views for a certain amount of the regularly occupied area, 50%, 80%, 90%, as well as glare control. So they have recognized that in the value for federal employees. And this resulted, there was also studies on the productivity enhancements and aspects. That's the reason it's included in there. So the next question I wanted to raise, really, maybe this can become a discussion point too, is what about the base codes? I spoke about green codes. We know LEED buildings. We know Green Construction Code. We know really the best buildings. But what about your everyday building? As Lisa's talked about, or at least I've heard her talk in other venues, is access to views, natural light, and quality indoor environments, is that only for green buildings, or is it really a fundamental right for all? Why is it only for certain buildings? It's really should be a fundamental right for all. So that means we needed to get into the base code. In this case, the International Building Code, IBC, that's widely adopted across the country. It's like, instead of really stretching at the top, how can we set the floor and make sure that we're doing the best even for minimally compliant buildings. And right now it's kind of disappointing. When you look in the IBC, it does require all spaces to be provided with light. And that can be natural light or artificial light. Well, for the most part, buildings have not been designed without artificial light since the 1800s. So this basically means that, all right, you're going to have artificial light in there anyway, as you should, but that really means that you don't have to provide natural light. And in their context, they define that as a certain amount of glazed area, kind of like the views in the green code, but also looking out in a public way, yard, or court. So all that's good, but it's not actually required. It's not guaranteed to provide natural light or views, even in the most critical spaces like schools. So I wanted to point out that there is a proposal under consideration right now for the 2024 IBC, which would, for the most critical space in my mind, classrooms, require both natural light and artificial light be provided for over 50% of classrooms in new schools and daycare centers. And so, especially, I mean, that's under consideration. We'll see if it goes forward. I hope you are all designing to that already. But for those spaces that are not, we encourage you to ask AIA and others to support that proposal. But we hope to see this move forward kind of as an equity type issue as well. So that's kind of just a quick summary. Oops, got a little echo there. And with that, I think I'm handing it back to Irmela.
Thanks, Tom, and thanks, Lisa and Steve also. Now that we've heard how important views and daylighting and our connection to the outside influence our minds and bodies and overall health, how can a designer or an architect balance what we understand qualitatively compared to the quantitative requirements in the codes? And Tom, you kind of touched a little bit on that, but it's more of like, how do we push that envelope? Forget about the energy aspects of it, but how can we now incorporate something as biophilic design into the codes? Tom, you might be muted.
Nope, my apologies. Yeah, so it's a complicated process. There's politics, there's negotiation, there's code writing. It's a little different than like you said. It's a nice to have. We all understand the value, but how do you put that in the code? One thing is, I would encourage people to reach out and support this proposal at the AIA, or to ask the AIA to support this proposal for the IBC. But also, regardless of what happens in the codes, look to the green codes and standards when doing your own design. Even if your overall project is not slated to be a LEED project or not slated to follow the International Green Construction Code, for this aspect of it, you can. Look at it, include that in your designs, look at it in your specifications, ask others on how best to do that. But especially, and as the screen there, some of these pictures going by, these are school projects that all the ones shown there are net zero or LEED platinum. And so it's also achievable to provide connection to the outdoors and views and energy efficiency. Now that's going beyond code. And again, I really want to stress, we also want to raise the base and try and enable the base codes to require minimum views as well.
Well, can I jump in here, Irmela?
Of course, yes. Go ahead.
I would like to emphasize that our building codes are the legal minimum standard of performance for a building. And we would like to expect that architects are bringing a lot more to the table than simply meeting the minimum legal standards. That because architects inherently integrate across all aspects of the needs for buildings, those long lists that Steve put up on one of his early slides, how to bring that all together and produce a product where 1 + 1 doesn't equal 2, it equals 5 or 10 or 100, because you're achieving a win-win integrated design. So I'm going to argue that architects are really the key players that have the skills to understand all these different components and bring them together into a synthesis that's more than the sum of the parts, and that providing beautiful daylighting inside of the buildings and beautiful views from outside of the building is one of the greatest gifts that architects can really provide to their clients and all the future inhabitants of their buildings. That's their strong point. So,
and I would add, this is Steve. I would add that process starts way back when you're first talking to the client, because clients may or may not come to the table with a clear understanding of what the options are, what the trade-offs are, what the limits are. They may have heard or been told by others, oh, you can't do this, you can't do that, which frequently is not true. So I think getting that on the table early in the process is really critically important. And I mentioned cost multiple times. Cost is always an issue, but there are creative ways about thinking about the cost side as well.
On that cost
issue. So one of the things I've been hoping to do is help architects develop better arguments for why this is really important and really valuable. Go ahead.
Yeah, I was going to jump in there on this issue of cost. So I'm an engineer, so from that I understand how we can do things to make a facade more efficient, and then capture that on the mechanical sides, and there it's a problem about getting everyone to talk at the right time. But in the maybe less engineering side of it, and this might be getting at what Lisa's talking about, is do we question the value of clean water? Do we question the value of indoor air quality? No, generally not. People understand those are important health, safety, developmental aspects, and view is really part of that as well. And so that's kind of a little less nuts and bolts, but how do we, and especially your community, the architects, have that conversation with the building owners of, you don't question the value of clean water. Why are you questioning the value of views? And because they're really one and the same.
Yeah.
Agreed. And with society, more these days, especially working from homes, and you see a lot of downtown office buildings empty. Do you see a shift for a different style of building, especially with, hopefully architects and specifiers are working with the building owners? Do you see something a little bit different coming along? Steve?
Well, I'll okay, go ahead, Steve.
Go ahead, Lisa. Go ahead.
All right, I'll jump in. I would say that certainly one of the lessons we learned during the pandemic is the value of access to the outdoors. And it's more than just fresh air. It's access to sunlight and space. And it turns out that studies have shown in buildings with views, people spend more time outdoors, that somehow it seems to prompt them and motivate them to get more exercise, to spend more time over the course of the week outdoors. Office workers who sat next to a window spent more time overall outside. And so this visual connection helps provide the actual connection. And I think that now that we understand how valuable that is, our outdoors are also going to become healthier. We'll have electric cars with less pollution, less noise pollution, but we can also really relish our own emotional connection to that outdoors.
Absolutely. Steve, did you want to add something?
Well, just I think with the response to COVID, there's been a lot of thinking or rethinking about indoors and outdoors. I mean, the ventilation piece was the driver initially, but I think it's just opened up the kinds of issues and questions that Lisa just highlighted. So I think it's been interesting to see all of a sudden all kinds of pop-up restaurants appearing outside, not generally glazed, just open. But I do think that there's a challenge in all these that with view comes the potential for glare and the potential for overheating. With these other aspects, with the ventilation aspect, if you've got poor air quality and noise outside, you want to be careful about managing that. So it's still a systems problem, it's still an integration problem, and it's still a challenge that needs the smarts of an architect and a design team to sort them through and come up with a solution that delivers, well, back to Lisa's point, that 1 + 1 = 3 and not 1.5. She said 5, I'm saying 3, but that's okay.
Yeah, I'd like to be optimistic. But Irma, can you go back to the photo of the Singapore airport, which is certainly a grand space. But one of the interesting aspects here, I think, is that if you are designing a space that is supporting plants and the plants are growing and healthy, you have to also be designing a space that is providing that kind of circadian stimulus for the humans also. And so we could sort of think of plants as an indicator species. They're like the canary in the coal mine. If a plant won't grow where you're living or working, there might be something wrong with the air quality or the lighting quality in that space also.
That's a good point. And of course,
I mean, there's also a design issue here. I'll just come back to the design issue where you've got to pick the right plant. I've seen lots of indoor spaces with plants where they've got monstrous electric lighting systems because there was no daylight, there were no skylights, and apparently they picked plants that needed a lot of light. So one needs to factor those kinds of issues in here as well.
Agreed. Well, before I turn it over to Dean for audience questions, I have a quick round for all of you. Can everyone really have a window?
I would.
Tom?
My answer is yes, with the exception for where it's programmatically not part of the design. Movie theaters, stuff like that. But if we're talking schools, healthcare, offices, yes.
Yeah, I
think it's really important.
Go ahead.
I think it's important to emphasize that having windows is a social choice that architects and building owners are making. And it would have been really easy for NASA to decide that it was too expensive and too technologically challenging to put windows into the space capsules or the space stations. But astronauts insisted that being able to see out, being able to understand where they were in relationship to the planet, the moon, was essential to their well-being. And so the astronauts got windows. And those windows have turned out to be one of the most important and magical aspects of our whole space program. So I would make the same argument that occupants of buildings can insist that being able to see the outside world is important to their health and well-being.
Great point.
Absolutely. I'll go ahead and turn it over to Dean.
Okay, thanks. Thanks, Irma. And thanks, Lisa, Steve, and Tom for a great presentation. We've gotten a lot of questions in. I just want to remind everybody who's listening in, at the end, we will provide you with a survey that can provide us impact on how to improve these going forward. But we've got a great one here, so let's get to the questions. We had a couple of questions that focused around a theme with respect to buildings. In terms, I think, Steve, you started to get at this, but in terms of how you vary the glazing on the various sides of a building, both from the standpoint of daylighting and energy, but also, I guess, in terms of view, which we're talking about as well. Maybe you could talk a little bit more about that and maybe the cost impacts of it, and then maybe Lisa and Tom, you could pick up the same question. So it's about, do you vary the facade in response to the outside on all four sides of a building, which we see fairly little of nationally?
Yeah, I mean, I think the obvious answer is yes. There are reasons, there are a variety of reasons why people don't do that. One is sort of style. The other is that it's cheaper to reproduce the facade on four sides. But if you want the facade to be the proper interface between human needs inside and the reality of outside, then you need to pay attention to orientation, you need to pay attention to adjacent buildings and space and all those kinds of functions. The good news is there are solutions for all of them. The bad, maybe it's not bad news. The reality is it takes a little bit of extra effort because you now have a different facade on each of three or four sides. And you can do that in modular ways. You can do that in a way where there's a central panel that's sort of or a central glazing element that's constant throughout and provides the minimal view, and then you can have larger or smaller other technologies added as a function of orientation. So I would argue that we should be adapting solutions to climate and orientation on each building. And that also gets into the footprint of the building as well. You're seeing the slides you're showing now sort of touch on that a tiny bit.
Yeah, and the shading, what we flashed through there was several options for external shading, whether it's sunshades or grills or, automated louvers, things like that. And those can be orientation dependent as well, where obviously, west versus north. So.
And there's a climate piece here too, that it tends to stay away from windows, larger windows in northern climates. But the technology exists today to make windows almost as insulating as walls. So if you need the view, if you have the view and you need it, you want it, if you spend a little bit more on high performance glazing, you can provide comfort, thermal comfort as well.
And Lisa, you were.
And I would add that while orientation is essential, the sun moves, we need to pay attention to sun shading. Views also change by orientation, and whether you're looking out into a sunlit environment as you would if you were looking north in the northern hemisphere, or you're looking into a shadowed and silhouetted environment because everything is heavily shadowed from direct sunlight. And that changes during the day. And then reflections outside change during the day. And so providing occupants with the ability to control and modulate the quantity of light coming through the windows and the intensity of the view is really important to success. So we can do a whole lot with just the facade of the building, but then there needs to be another layer which provides that level of very small grain occupant control.
Okay, maybe sticking with you for a second, Lisa, there were a couple of questions about studies and references. One to the discussion that you had about myopia, and then I think there was another one, I'll find it, about a different study. And then also in terms of where do we stand now in terms of the variation, the value of the quality of view. I mean, I'm sitting here looking at a wall, but I have a big window. So, I mean, is there research looking into that in terms of, the relative value of quality of view, independent of the high rises that you showed, but is there research work being done in that area?
Okay, so quickly on myopia, there are studies. I would urge people to Google myopia and circadian. These studies are also referenced in my book, so there are citations in there that you can follow. Relative to the quality of view, that is just becoming a topic of interest among researchers. Especially, we see more of this going on in Europe with trying to understand how to quantify the quality of a view. One very promising approach here is looking at what's called the three-layered view of incorporating elements of the sky, the ground, and mid-ground into a view as the highest quality view. There's a lot going on, obviously. I think that one of the very important aspects of view is this sense that it allows you to project yourself outside, to think about what you might be doing in the future. It sort of connects you with where you might have a place to be. And so, yes, research is starting to show up, but I would say it's really at the very much the beginning of this topic area.
Terrific. Okay. Yeah, the other one was a question about if there's any guidance on percentages of glazing for view that are recommended. Is there anything in your book or in your references about that?
I would reference the SMUD desktop study that tries to get at that, but also look through LEED, which has some references.
Great. Okay.
And just to jump in real quick, there are different ways people are measuring it quantitatively. Some better than others. They're not really getting at the quality of the view, but in terms of the amount of the view, you can use view factor, which is kind of related to angle. There's also some minimum glazing to floor area ratios that they recommend, like often 7-8%. But that you have to be careful. That can be it's abused if it's not within a certain distance of the window, for instance. So
now, of course, right. A crucial issue is where people are with respect to the window, independent of the size. If you're 100 feet away, it's sort of irrelevant. So that floor plate issue and the interior design issue becomes important as well.
Exactly.
Terrific. All right. Well, I'm afraid we're out of time. I'd like to thank Steve and Lisa and Irmela and Tom for a really great presentation based on the questions that we've gotten in. Just a quick observation in terms of how long these issues have been around, at least 100 years, because in 1922, a documentary called Nanook of the North was filmed, and it showed Nanook building an igloo out of snow. But at the very end, he put in a piece of ice as a window and a daylight access point. So I think the combination of these issues have been going on for a long time. So in any event, thank you all very much. Thanks to our panel, everybody. And remember that we have any additional questions, you can please email us. Please fill out the survey and visit architecturerecord.com/webinars for the archive of this presentation, as well as information for upcoming events. We appreciate your time and hope you found this webinar to be valuable. Thank you very much.